Okay, video number 8 of the How to Wire Schneider PLC series. We are working with the Modicon M221, and today we are going to be looking at sourcing DC outputs using a relay model. So specifically, the model that we're looking at is going to be any of the TM221s that end with that letter R. Once again, anytime that you have got these two positions inside of the model name, they're going to be a C, an M, a CE or ME for cartridge or monolithic, and then you're also going to go and have the number of IO points that's going to be designated as per these ones. None of that really matters. Whatever combination you have for those two positions, it is just the R that we are going to be dealing with in this video. If you have got a T or a U style, you do want to go and check out the playlist and look for those T and U styles and watch them inside of there. All right, rolling on here. When we're taking a look at these, the models that we're going to be using, the CE16R and the MR that we are going to go and have, they do have a relay output of 2 amps, and they're going to have a common output of 7 amps. And so as a result, they do give us a minimum AWG size. They would like to see at least 20 AWG. If you go smaller, there's too much heating that happens from current flow going through them. So they're looking for 20 AWG minimum. And for your commons, they're looking for at least 16 AWG. Going a little bit further into the manufacturer's documentation, over here it tells us a little bit about the actual outputs. They are going to be a relay style, normally open. They're designed for a rated output voltage of 24 volts DC or up to 240 volts AC. And the AC rating is way higher than the DC because the AC crosses through the zero axis anywhere between 100 to 120 times per second, depending if you're 50 or 60 hertz, which means that the arc is much less damaging. It's easier to go and interrupt because it does not sustain in the same way. So pick whichever one you're going to be using, AC or DC. There is a video on how to wire using AC. That's not this video. We're going to be working with the DC, which is going to be 24 volts. They've got a minimum switching load. They have got a rated output current. That's going to be an important one to us. 2 amps per the output, and then 7 amps for the common for my maximum rated output voltage. And that's because inside of the PLC, we have got all these little relay contacts. Just draw them in here, Q0, Q1, and Q2. This would be Q0, Q1, Q2, etc. like that are all going to be sharing this single branch here. We call that thing the common. So the common has to be rated for 7 amps because it's going to be carrying up to 3 of these as current at a single time that we are going to go and have. 4 of them current up to one time because it's going to be Q0 through Q3, and then the next one's going to be Q4 through Q6 over here. Okay. Diagrams are given inside of here as well. They do give us relay output diagrams for what we call positive logic or sourcing style of outputs. There's a safer style of outputs, considering that most often, if there is going to be a grounded DC supply, it's going to be negative grounded. So this is the one that, generally speaking, will get you in less trouble. They do show you on their manufacturer's documentation as well the AC and the DC superimposed. They're not saying that you're going to be using both at the same time. They're saying that you are going to be using either one of those. So we could scratch the AC that was dealt in another video over there, and we can take a look at the DC. They show that we've got our DC positive over here, that we should be taking that through some fuse protection over here. They're once again recommending that type T fuse. It goes into our common, and then from our common, it is going to go and switch out through relay types of contacts to each of these. Of particular note in here is also this little symbol right over there. That symbol is standing in for one of these, an RC snubber or a DC freewheeling diode that's going to be in parallel. The reason for that is because your actual relay contacts are opening and closing underneath current, which means that there will be some inductive kick whenever you get that collapsing field around the DC contactor coil itself. So since we're dealing with DC, we are going to be looking for this freewheeling diode. And what those freewheeling diodes actually look like is specifically just like this. This is an LA4DB. It is designed for AC or DC, and it is going to be a suppressor module that is going to be connected directly onto your contactors. They show that on the side over here, just like these ones. They click in. There's 2 little spots just right underneath the coil over there, so they don't take up any extra space inside of your cabinet. It's not extra wiring. It is simply just buy it, open the box, click it onto your contactor, and you have at that point got this thing protected. So that is what's being shown right over there, that you're going to add one of those on. Now do note that they say this is to improve the lifetime of the contacts and to protect from potential inductive load damage. Onto there, they're not mandated, they're highly suggesting it. AC, you can usually get away without these. DC, I would never attempt to go and play around with DC contactors without putting one of these in, unless I knew that the contactors I was using already had one of these placed in. Okay, now that we've got all the datasheet explanation done, let's roll on to take a look at some of our options. First one that we have over here is going to be my CE cartridge edition. That's the cartridge space inside of there, Ethernet connection that's available, that's the Ethernet jack over there, and a relay type. Now we have gone through this one numerous times in other videos for the different types of inputs, and we know that there is this little DC power supply that's going to be on there. However, that DC power supply, go back through manufacturer's documentation, is limited to 250 milliamps. It is designed for inputs. It is not designed to be running out a lot of outputs. Since our outputs, our coils, are usually going to go and take a bit more power than that, we should be using an external power supply. So we see that we have got an additional piece of equipment now that has been introduced into this circuit. Before, all that we had when we were using those was we had the fuses. Sorry, I should start right here at the very beginning. We had the DIN rail breaker feeding over to the fuse holder, which then fed my AC directly raw into this PLC over here. Now what we have to do is we have to add in another AC line. We're going to go and convert that into DC through a DC power supply. And then we're going to go and take that DC that we have, and we are going to go and take it through a fuse holder. Once again, so that we can go and put in proper sizes fuse. The ones that were designated inside of the manufacturer's documentation is they wanted a type T fuse. If you're using a CC style fuse holder, which is easier to get a hold of than the type T's, then you would be using an HCLR style of fuse inside of there. All right, let's carry through with our powering. Now we are working with a sourcing output, and a sourcing output means that we are connecting the positive to the common. So we've got that fuse positive that we now take into the common, and then what we do is we go from here out to my actual coil. So we're going to go out. We do want to eventually power up the coil. The coil is going to be positive on A1, negative on A2, the way that these coils are. But we also want to make sure that this contactor is going to be able to trip if it goes through an overload. So we're going to take it through these normally closed overload contacts. If you don't understand the guts of a relay, you must understand the guts of a relay before you really get very far into automation, then watch on my channel. There is one where we completely explain through the contactor section and the overload section, how they work together. We're going to go and use those normally closed contacts inside of there. So I'm going to come out of Q0. In other words, inside of this relay, I have got inside of this PLC, I've got a relay that's going to close that path like that. I'm going to come out of here, go into one of my normally closed, and then out of that next normally closed up to my coil itself. And then from the coil itself, the opposite side, the negative side, we then need to go and take a line back home. We'll do that over here, up to there. And at this point, we have got a complete path for current path. Our current flow, we'll cover through that. We got the fuse holder. We have that going into the PLC, traveling through the common, going through the relay contacts, coming back out on the Q0, going through the normally closed overload block over there, up to my coil, traveling through the coil itself, and then traveling back along my negative to my DC supply, like that. Exactly what we are looking for when it comes to a DC sourcing type. What we can also do is we can go and use some of these other contacts that we have on here, particularly these two sets of contacts. We've got a 1314 normally open, and we have got a 9798 normally open down here as well. This set of contacts will close anytime that the contactor is turned on. So if I wanted to have an input telling my PLC that I've got this motor running, I've called for it to run and it's actually started running, I could take an input off of these. And this one down here, what I have got is a signal that is only going to close anytime that my overload trips out, kicks out my motor that I'm going to go and have. So I could use that for a signal back into my PLC that is then going to be able to stop the PLC because the motor itself is overloaded. These two if you want, could come off of this power supply. You could also, if they're going to be used going into the inputs, take them off of here. So we'll just set them up as a syncing style of inputs, which would mean that my negative goes to common up top over here. We'll just erase that 250 milliamps. It's going to be in our way. We would take this one out from here. I don't have another fuse holder drawn inside of here, but you would end up sticking another fuse holder in place, and then you would go from there, you would drop that 24 volts down, pick up one of these, and pick up the other one of these. So you've got power fed in, and then from there, you would then go and take another line back off of each one of these. So you take one back from here into one of your inputs. That's now going to go and tell you whenever you have triggered an overload, and you would take one from here. That could go and run from this one back in. We'll stick it into input number 2 like that. That would be able to then tell you if you actually have called for this contactor to start up and if it actually has started up and pulled in. Really, it does provide a redundancy that you are going to go and have. You could get away from this one over here on the overload by just monitoring this inside of your PLC program if you wanted. But these are all extras. Right now, this video is really focused around the guts of applying power, applying a sourcing type of output using DC and a relay type. And that's what we have drawn in here properly. Let's move on and take a look at our monolithic style. Our monolithic style, different body style. The inputs and the outputs are going to be run vertically over here. And we are going to go and do the exact same sort of layout. So we have got these ones powered up by DC, which means that we already have our AC in being brought in, taken into a DC power supply. That DC power supply then went and powered out two fuse holders that we have over here. One of these fuse holders provides power into the actual relay itself, or into the PLC itself. The other one is what we have sitting here waiting for us to go and do our control wiring with. So since we are looking at doing a sourcing output, that means we are going to go and take our positive into the common. So we are going to go and travel from here with a live line, and we're going to take that into common 0. That has now provided something that is ready for all of these to go and switch out. We then come out of here, and once again, we want to go through those normally closed contacts that are going to be inside of here, because that's going to be my overload, sensing when my motor is drawing too much current. So we'll come out of Q0. Why don't I just change colors over here, actually. It doesn't matter which one you come out of as long as it's Q1 through Q0, because that's associated with this common one. We will go out, and we will take that into one of these, and then we're going to come out of the other one through the normally closed to my A1 of my coil over here. That now brings our positive in. A1 is always your positive. And then the last thing we need to do is we need to just go from A2, this line over here, and all the way back over to our negative. And that's going to be our proper sourcing type of output from my relay type here, providing power over to a contactor. That's as far as we need to take this one. As we did in the previous example, you could go and do some monitoring using your inputs. These ones here, because they don't have an onboard DC, you would have to go and jump in some of your other powers. So you would have to go and take in a negative. We can jump that one in from over here into my inputs. And then you would also have to go and take in a positive. We could take that one from right over here that we have coming off this fuse holder. You could run that positive up, around, and then you could use it to pick up that normally open. And you could run that one down to pick up this normally open. And then you could run a set of monitoring contacts back from here to my individual inputs, whichever ones. We'll place that one in I3, and we could take this one into I0. And by doing that, that would allow you to go and monitor this one. This set right over here would go and let you know whenever the contactor has pulled in and is actually running. And this set over here would let you know anytime that the overload block has sensed too much current to the motor and has tripped out. But like we said before, these ones are not necessary for what we're looking at over here, so we will go and remove those. Last thing that we're going to do is we're just going to verify that power path. We do have power going from my positive through a fuse holder, from my fuse holder entering into the PLC, going through the internal relay contacts, coming back out, going through this normally closed setup on my overload, hitting the coil. That coil over there is going to go and energize, pulling my contactor, and then traveling from there back along my negative to my supply over here. That's it. That is our proper sourcing type of relay wiring.